So let's talk about the months. This is clearly about explaining the slope and the intercept in the context of a graph. And so I'm just going to point out a few things as you look at this page. So on this first example, you notice that the x-axis has to do with the number of days and the y-axis has to do with the pounds of food we had. So when we talk about the y-intercept over here, in red you can see I put 0 and 70 because 0 is the day and 70 is the number of pounds of food. That's how much I initially started with. So any one of those words would help me explain what's going on there. So the meaning is, at the beginning, there were 70 pounds of food. So then, when you look at the 12 on the x-axis, you write that as a 12, 0. That means on the 12th day, we ran out of food, or there was no food left, or 0 pounds of food. Any one of those things. And then we're going to do the slope. So you can see here in red underneath the graph that I started with, we went down 70 pounds and we went over 12 days. And so then we reduced that. And so because the graph is going downhill, you can see that it is negative. That's why it's decreasing. So when you work that out, it's however many times 6 goes into 35. It's not quite even. So you can see that 6 times 5 is 30. And so it's almost 6 pounds a day. So you're going to read that over here as negative 35 over 6. That's the rise over the number of pounds over the number of days. The meaning of that is every 6 days, the food decreases by 35 pounds. And if you wanted to reduce that to a decimal, that would be fine. It would just be pounds per day. Be very careful of the scale when you're talking about graphs that you did not create. Because unlike the graphs we've been doing up to this point, where it's one box down and one box over, you can clearly see how on the x or on the y-axis here we counted by tens. So when you're going down, yes, it's down 7 boxes, but it's really 70 pounds because each box represents a 10. So don't get confused by that. So then if you go down and you look at this second example, we have something to do with hours and temperatures in Celsius. So again, our initial value, it starts at 100 degrees. So 0 is 100 degrees. Initially, the temperature was 100 degrees. That's my meaning in words. When is the temperature 0? On the 15th day. So you can see here it's 15, 0 in red. And then the meaning of that is after 15 hours, the temperature was 0 degrees. So again, you're paying attention to your labels. So it started at 100 and it went to 0. So it went down 100 and it went over 15 days. So that reduces down to negative 20 over 3, which means the temperature decreases because the line is going downhill 20 degrees every 3 hours. Because remember, the x-axis is hours, the y-axis is the temperature. So fairly straightforward. Let's talk about when we write it in a little different format, where we just say, here's a graph, tell me the slope. Well, again, you have to pay attention to the graph. So when we look here, the x-axis is counting by 4s. So, and it's going up 1, so up 1 and over 4. So that's the baby grows 1 inch every 4 months. If I give you a random point like 8/22, that means on the 8th month, when the baby is 8 months old, it's going to be 22 inches. And a newborn, meaning at birth at 0, is 20 inches long. So you see how we just took what we know about the situation and we wrote a sentence to go with the numbers. So again, let's do another one. This one's on a lemonade business. So you can clearly see I'm going to go with the whole numbers. So it went down 16 and over 5. If you wanted to reduce that to how many by 1, you can see I did the decimal there, negative 3.2. So essentially for every hour past noon, the number of gallons remaining of lemonade decreases by 3.2 gallons. So 50 means at 5 o'clock there was no lemonade left because that is the x-intercept. It's when I'm out. And my initial amount was I started with 16 gallons of lemonade. And that happened at noon. Because it says down there in the little fine print, time of day, 0 represents noon. So it's important to read all about the graph. Then when you look here at this next example, it has to do with the number of days spent reading and the number of pages that I read. So you can clearly see that on the 0 day, I'm at 50 pages. And then on day 4, I'm at 350. So you're going up, if you want to work it this way. 350 minus 50 would be 300. Divided by 4, that would be 75. So 75 pages per day. So for each day spent reading, the number of pages will increase by 75 pages. So after 4 days, I have 350 pages have been read. And initially, we had started on the 50th page. So I don't know how long it took me to get to 50 pages, but that was prior to my starting the count. Okay, so with that in mind, let's go up here and let's talk about the assignment. So as you can see, I'm going to focus here on Louis' road tip first. You want to look for some key verbiage when you're looking at, let me erase this purple so you can see a little bit better. So you can see here I gave you 2 order pairs. So it went down from 400 to 350. So it went down 50 in 2. So that's our down 50 in 2. So clearly 500 divided by 20, that's also the beginning and the ending. Again, it's 50 divided by 2, which gives me 25. So I have 2 of them down here that talk about 25. So let's think about what makes the most sense. Was it 50 gallons in... Well, that's a little hard to read. It's a little bit off the edge there, but number of miles. Is it 50 gallons, I'm going to drive 2 miles, or is it going to be 50 gallons, 50 miles and 2 gallons? So if you're not sure, then let's just remember it's rise over run, which will be the Y's go on top and the X's go on the bottom. So if that's the label, it's miles per gallon. Wow, that's really messy. But it is miles per gallon. So see if I can make that show up a little bit better. Per gallon. So that's what I'm looking for down below. 25 miles on 1 gallon. So that was the answer. Clearly the 500 and the 50 don't make sense because we already said it was 50 and 2, not 50 and 1. So you have some clearly some bad answers here, so you know you can cross them off. So let's look at question number 2. It says identify the x-intercept and its meaning. So clearly that it's here on the x-axis. So again, I can cross out the 500s because that's my y-intercept. And so remember, x-intercept is 20, 0. So that would be 20 on the 20th gallon, I'm out of gas. So Louis can drive 20 miles before he runs out of gas? No. Louis' car can hold 20 gallons of gas. That is truthful because we know he had gone a total of 500 miles before he ran out of gas. All right, so let's talk about what's happening over here on the second question. This one has to do with Robert's taxi. So again, you can see I did a little bit of math here. I wrote the little order pairs a little bit bigger so that you could see them. So 22 minus 12 is 10, and 8 minus 4 is 4. So 10 divided by 4 is 250. So my slope is 250 per mile. And then it says, what is the y-intercept and what does it mean in the situation? So you can see here how it starts at 2. So that's $2 to pick me up. I haven't driven any far. So it's just $2 to get in the car and it hasn't even moved yet. Why does the x-intercept not make sense in this one? Because clearly he's not going to have the taxi driver pay him back any money. I mean, it's just going to keep having to pay more and more and more and more. So again, as you're moving forward in time, it's never going to go to the x-axis. And if you notice, to get to the x-axis in the past, you have to go back in time. Well, clearly we can't go back in time, so you can't go a negative distance on the graph. Okay, So what you're going to do then for me is you're going to finish the same thing. So there's a couple more on the back of that page. And then on the second page, it's set up the same way with questions very similar to the ones that we just did. So you're going to do those questions and turn this assignment in.